A common engineering task is modifying files only available as mesh file formats. For example, this bracket with inconsistent chamfers. This is usually quite difficult as mesh-based files support much fewer operations than BRep-based bodies. Simply converting it to BRep also often does not result in the desired behavior, as rounded surfaces remain faceted. To avoid having to manually redraw this part, we have developed a tool for fitting true BRep surfaces to mesh bodies. After installation, you will see the Fit Surface command in the Mesh workspace. Selecting it automatically selected the mesh body in the workspace. Below the mesh selection, you have a list of surfaces to fit. You can add new surfaces by pressing the Add Surface button or pressing the N hotkey. Below that is a slider for the selection radius. This selects all vertices in this radius around your cursor click. You can see the first surface is already there and the type is set to automatic. You can manually choose the surface type between plane, cylinder, cone and sphere, but automatic usually finds the optimal surface type. Let us start by first fitting the cylindrical holes of this part. We will select vertices only belonging to the cylindrical hole and not the conical chamfer. We can go in a top view, increase our selection radius to more easily select more points, then start selecting vertices on the inside of the hole. We typically only need a small number of vertices to select the face. You can already see a cylindrical surface has been fit to this hole. We can repeat this step with further holes. Make sure that you add a new surface for each new surface you want to fit. Even a more sparse selection results in a tight-fitting cylindrical surface. In some cases it might have more difficulty identifying the surface type. You can either manually select it, or simply add more points, which increases its certainty. Right now it's thinking this would be a spherical surface, but selecting more points will turn it into a cylindrical surface. You can see, it has correctly identified the cylindrical surface. Let's now move on to the last hole. We can use the N hotkey to add another surface. Now all 4 holes have been fitted. We can use the overextension slider to determine how far the surfaces protrude beyond the selected points. This is useful for generating watertight boundaries. We can confirm the conversion by pressing the OK button. This is already sufficient if we simply wanted to measure the distance between holes or the size of holes accurately. We can however continue reconstructing the entire part. We will now start reconstructing the planar surfaces, ignoring the chamfered edges, as this is what we want to fix later. I will start a new conversion session by calling the command again. Reduce the selection size so we only select the points we want. Try to avoid points outside the surface as this significantly decreases the accuracy. If you do select a point outside of the desired surface, you can simply deselect it by shift-clicking it again. We have now gone around and created one loop of faces. Now for the end caps. We can select vertices even through already fitted geometry, and we can see the mesh through the blue outline. Here we can see the generated face conforms to the point selected with an offset. We can change the shape of the generated face by adding more points to prevent holes and corners. We can reduce the overextend temporarily to make it more visible, and then select the missing corner. We can now inspect the fitted surfaces to ensure they form a watertight boundary. In this case, we still have gaps where the old chamfers used to be, so we will increase the overextend until these gaps are closed. Some overlap is usually okay. Adjust the overextend so there's some overlap. This will soon be boundary filled, so the overlapping surfaces will get trimmed away. A quick visual inspection shows that we have captured all the surfaces we want, so we can now confirm the selection. We'll now go to the Surface workspace and use a boundary fill feature. We will select all surfaces and then select the cell corresponding to the part we wish to keep. We can check the Remove Tools box so the surfaces get removed, cleaning up the browser. We are now left with a solid part closely resembling the mesh. The surfaces are usually within a few nanometers, so no loss in accuracy is expected. We can now do the operations we came to do in the first place, like fixing the chamfers or doing other modifications. We have now added an even chamfer. And just like that, we have quickly fixed the uneven chamfer on the mesh file. We can also reconstruct other surface type, like the conical surface of the existing chamfers. Here we can see a cone matching the existing chamfer. The four surface types currently supported are planes, cylinders, cones, and spheres, with more being added soon. Thank you for watching this short presentation. We hope this tool streamlines your process and makes it easier to modify mesh-based files. For more information and links to download this program, check the video description.